All right, so let me show you uh, what we're working with here. Pull up Visual Code, and gonna need two. I'm using Windows Subsystem Ubuntu, Windows Subsystem Linux WSL. Okay, you should have devkit repo, and I'm using the old TFN core. I'm not sure what the newest setup is, but you should be able to follow along. It's basically just getting the zero state into the validator engine, however you've got your validator engine running. Um, I've got a I've got a test script which I can show you that automatically starts validator engine, and it also starts the blockchain explorer here. So it's just a little script. It kills any running versions here, you can see, and it removes the ton work from the previous run, and then this here starts a new configuration with the zero state. And here you can see you might need to change this, but you can see that I'm backspacing into my home directory and then going into devkit, my devkit repo, and then under sandbox is where I'm producing the test zero state, and that's the fifth. So I just want to show you everything that's going on here. So if things don't quite work on your setup, you'll understand. Uh, and then it runs your blockchain explorer here. um, so this test ZS fifth, that's under devkit. That's under the sandbox here. Uh, test ZS fifth. I basically just copied the original zero state, but I took out maybe a contract or two, and I changed some things. I gave us more gram to work with, obviously with our test giver, uh, because 20 gram wasn't really enough. I think I'm using like 5 million or something somewhere. If I can find it. Which one is it? I think it might be this one. Uh, Anyways, it's here. Here we go. Faucet S1. This is uh, what this is doing here is it's calling to include this Faucet S1ZS include. That's what this file is. And this file is what gets regenerated. So uh, this Faucet S1 file, the this that we're looking at here, this file, the test ZS fifth, this does not get regenerated. Uh, this just stays the same because none of this stuff is going to change. And what this file does here, what Faucet S1 ZS include does, is it it creates a variable Faucet S1 code and Faucet S1 data, and and that's kind of the same as any of these other contracts here, where you're seeing the code cell, it creates a cell, and then the data cell is created here, and then you have your libs, and then it generates the contract inside the zero state here. So that's basically all this does. But instead of uh, Faucet S1ZS Inc. just defines these variables, the code and the data, and then that's used here. So we take a look at the one that was generated, Faucet S1ZS Inc. Here you can see the code that's generated of our Faucet S1, and then here it generates the data. So these are constants, actually, not variables or whatever. But now there's some other stuff that get generated. And first of all, I'll just show you how this works. In DevKit, you do yarn, uh, gen, I always forget it so long. Gen faucet, S1, ZS, Inc. And you'll run that, and this will automatically monitor. So you actually want three screens here. But what this just did was it created these files. It creates in in the sandbox directory, it creates this config if it's not already created. If this config already was created, it loads the config and uses those values. If it doesn't, it needs that, and it also needs the master seed and the bot seed. If these aren't here, then it will it will generate them uh, randomly. So this is for if you want, like you said, separate the bot uh, from the master. If the whatever entity is in control of the bot public key uh, might not be the same as the master. So this all might not be done in one place. You might just have the config. These seeds are actually only needed for testing. Uh, to actually run the validator engine with the zero state, you only need to run uh, the ZS config over here, and and you can supply the config.json if you don't already have one. All right, so that kind of explains a little bit about the zero state stuff. So the rest is pretty straightforward. So I'll just run my test sh, and that will start up an engine, validator engine. It's generating the zero state using whatever's here in this config, using test ZS, which is including this file, and that's our contract. What I've noticed is that when these are 76, it's not running. We can go ahead, at this point, we can go ahead and pull up our browser and go to localhost 8083 /last, and we shouldn't get anything because the connection isn't ready. We can see that here. The connection's not ready. As long as the packet size are 76, it's not ready. When it's 200 and something, you'll see one that says 200 something, you'll know it's ready. So we're gonna have to wait for about a minute or so. There it is, 288, and then you know it's ready. I can go ahead and refresh this, and we'll see. I guess I could be wrong, or I could have an old version running. That's quite possible too. Let's see if I've got an old process running. Sometimes with Windows Subsystem Linux, it gets a little crazy. So I'm gonna stop the Blockchain Explorer. validator engine. Looks like one might have been running from before. Blockchain. Okay, so that's not. That's a bit loud. Okay. All right. Let's. Hopefully this will work. This is kind of the pain of developing this way. I have thought and thought and thought, but I don't. I'm not sure there's any better way without going in and fixing tons code, which would take probably a year just to, maybe 3 or 4 months to really get familiar with it enough to fix it. Let's see. We shouldn't. Let's see. Blockchain. Yeah, I think this is good. It shouldn't be showing anything yet. Okay. It looks like. I don't know. It should be working. Okay, there we go. Finally. Try to get that situated here. I'll put it on this half. We'll just cover up. Keep that and that. And we'll go ahead and run our main test here. So we'll go into dev kit again and yarn test faucet. It's version 3 for now. I didn't put S1, but this is the S1. That'll probably have to be changed later when we have the stage 2 version. So if we run this, it should work because we have a validator engine running down here. This is what you're seeing here is not the validator engine. That's running in the background. This is actually the blockchain explorer here, and we don't need to see any of this. This doesn't help us. But this is good. This the gen 0 state, and this is basically testing the faucet. What this is going to do is it's going to try to register 7 benefactors, and you can see that only 5 got registered. This is your main contract. I'll start from the beginning so it makes sense. So what happens is we created uh, we created an object here. I'll show you in the code. Circ, not dev, SDK, com. Uh, it's not in any of that. It's in test faucet v3. So I'll take you to the code and take you to the output, so it's really clear what's going on. I'm gonna throw this over here. Okay, so here's what we do. We're this we're getting the wallet contract, just the standard wallet. We're gonna need this for main down here. Uh, Faucet v3, I created this utility which will load signers. So it's basically going to look in Sandbox for these seed files and load them. So taking the bot and the master seed, you've now got the signers for the bot and the master. Config loads the config that was generated here, and it will have the values like the sponsorship price, whatever that is, the max number of bins, which I've got set to 5 instead of 32 right now, just for testing, so that all this doesn't take forever to see the end result. So 5 for now. Pay base is what you get. You get when you sign up or when you register. Um, so where was I? In test. I'm looking for test. There we go. So that's the config, and that's needed by something in here. I guess it's just needed down here to pull out the sponsorship price. Um, anyways, there's that. So F1, this is our faucet as stage one. This is uh, this is kind of it's it's the account for uh, talking to the faucet. If we're sending messages to the faucet, you need to create this object uh, by giving it an environment and the address of uh, the faucet S1, which is just a bunch of sevens, as you can see here. And that also translating to this is the base 64 versions. All right. So the thing about this is I had to make it hybrid because there's going to be some situations where you want to do similar things, like you want to send a message, but you don't want access to the signer. So you can create this object without having a signer because you might just need it to send messages to the faucet. Like this wallet needs to send a message to the faucet. Uh, sorry, this wallet main. We're calling it he's going to be the alpha, the original um, main wallet. Sends messages to the F1 contract, uh, and it uses the F1 object in order to do that. But since we're also uh, testing um, some other things, because uh, we mainly only need the signer, the actual private key of the faucet. We need this here because we're we're calling this reset operation. And we do this because if we don't, if we want to rerun this test with different configurations, but the contract hasn't changed, and we don't have to restart validator engine, then we need some way to remove the user data that's inside the contract. So that's what this operation does, this reset operation, and that's why we need the signer uh, because you have to sign the message so that the contract knows that uh, you're officially capable of resetting. Of course, in the final contract, there's not going to be any resetting, so that's all going to be taken out, but it's necessary for testing for now. Um, so moving on, sending message from main to become first sponsor. So this main wallet, this is just a normal wallet. It's going to send any amount of gram for now. We can create another configuration value, but I just have whatever. Uh, the first wallet to send any amount of gram to the contract becomes the first sponsor, basically. So we're using the non-bounceable address for. We could have used any address. Probably. Actually, no, I programmed it in there. Uh, or no, I didn't. I changed it. Anyways, never mind. I guess for now it doesn't matter if you're using a non-bounceable or the bounceable address, but I was gonna make it to where only non-bounceable address should be used, and that's possible. Um, and then what happens is, so let's see that resetting. We'll look for that here. We'll see that resetting. All right. So before that, we gift and deploy the main wallet. That's what happens here, and we gave it 555 gram, um, and that shows that it was gifting it. The balance changed, and then it deployed it. And then we reset the contract in case there was any old data. So we do that by sending the op reset. then then we actually send Graham from the main contract to the Faucet contract, and it becomes the first sponsor. And show users is showing you the users inside the contract. So it's basically, this is actually an address, but it's the, instead of 256 bit turned into hex, it's actually a number that is, it's an integer that's 256 bits, an unsigned integer. That's why it's so huge, and we're having to use big int, which that's why there's an n at the end. You should know that. And it has no beneficiaries right now. See, 0. Um, and then we show info for F1, the main contract, the faucet contract, and the main wallet. And that's what gets shown here. We can see that the state is active, and the balance is a shitload of gram. And for the wallet, uh, its balance is roughly under 555 because we just sent some to the contract, to the faucet. All right, and then the sponsoring starts. All right, so we do that here, do sponsors. Come down here, here, do sponsors. Uh, it debugs sponsoring, that's why we see this message. And then sponsoring bin number, whatever the uh, loop iteration is, bin 0, bin 1, bin 2, bin 3, bin 4, bin 5, and bin 6. That's a total of 7, as you can see. And but we saw that in our configuration, we've limited it to 5 for now. And so 2 of those shouldn't work. The last 2 should not get sponsored. And we're able to verify that by checking the users again. We should have 6 total users in the contract because 5 were beneficiaries of the main contract, and then the 6th is the main contract. So that's what we have: 1, 2, 3, 4, and 5 that have no beneficiaries because they're children, and then this obviously is the main contract. The only way to know this right now, uh, because these addresses are just big numbers, is the number of bins. So we can assume this is working properly. Uh, Later on, there could be more work done to like write. I could write a utility function to turn this number into hexadecimal. So we can compare that and make sure that this user is actually, or also, and you need to convert it back because when in the contract, you can take a look at it, you're able to query users, and so you can see what kind of data is inside the contract. It's not necessary for live, I guess, but you certainly need it for testing. And since it's part of the system anyways, I think it's probably good to have in there, uh, just to make sure everything's working properly. Um, so that's here, not there. This is the configuration. See, we have sequence number. These are our method IDs, our get methods. Sequence number, get first user. You need this to even get any user. And if there is no first user, it's going to return -1. So you should check for -1. If it's -1, then you know there's no users in the faucet. Um, so once you get the first user, you can check its user info, and that's using this. And that should return the number of bins for now. Later, I suppose there might be other data, but for now, that's all we have is number of bins, benefactors that is that it has. And then once we've checked him, we go to the next user by calling this get next user. You send back this integer address. So that's why later on, if you already know that that your wallet's in there, and you don't know what your wallet's integer number is, you're going to need some code to go to convert from hex to an integer. It's not complicated, but yeah, that's basically it. So I mean that is basically our test right now, and it's showing that the users are inside the contract, they're there, and there is a limit because we know that we tried to sponsor seven individual beneficiaries, but we only got five. Only five went through. Anything more than that, you're basically wasting your grams, sending it to the contract. It'll take it, it'll eat it up, it'll eat your grams, uh, and we might change that. We might have it bounce back, but uh, I think it's always good to go ahead and eat the grams to uh, make sure that people who are doing this are people who know what they're doing and are and not just people who are trying to look for holes or try to abuse something. It's better to eat the grams. Anyways, that's my opinion. Um, then we have like a final output here. And we'll go back to our test. And so after all of the do sponsors, now it's showing the users again and it's showing the info of all the accounts. So this is showing the users here. These are the users in the contract. This is the info of all the accounts. This is your beneficiary 0 through 6 and main. And we can see here that because the first 0 through 4, which is 5 beneficiaries, they got sponsored, and that's why they have a balance because the faucet actually sent them gram. Uh, and it not only did it send them gram, it sent the main a lot more gram. That's why you see main has a lot more. Of course, it started out with a lot more, but uh, that this test could be refined to actually calculate and verify that main is actually receiving gram 2, but I am almost 99% positive it is. And you can see that the fifth and that the well sixth and seventh ordinal 5 and 6 didn't get anything. Their state is still empty. They have no balance because the faucet refused to sponsor them because the main wallet was already maxed out. And I think that pretty much explains everything that's going on. So just to recap, the most important thing to begin with is you need to run this. Uh, Gin Faucet S1ZS Inc. You need to run that to generate everything in the sandbox that's needed. If you want to refresh or if you change something in the code about, say, anything that has to do with what's in this config.json, then you need to delete config.json. So if you change the default sponsorship price inside the code, which is under Faucet v3 config, if you change that here, which is I believe here, so the default sponsorship price, the default max beneficiaries, the default pay base. If you change this, any of these, then you need to delete this config. Otherwise, uh, sandbox config, faucet s1 config. Uh, Otherwise, what's going to happen is it's just going to use whatever's in this config file, and it's going to ignore whatever defaults are in the code. So you could just change the numbers here and then rerun your Gen 0 state, and it will regenerate the contract with those values um, from the config.json file in Sandbox. All right. So to recap, Gen Faucet S1, you need to run that, and it's yarn Gen Faucet S1 ZS Inc. and inside DevKit. Um, if if you want to go ahead and pull TFN core, you can just take a look at basically, all you need to know is this test ZS fifth. If you keep this inside DevKit and inside the sandbox, uh, it will properly. This script depends on Faucet S1ZS Inc. fifth. So this one and that one, I'm gonna later take out all the stuff we're not really using. But some of those are utility scripts that I may come in handy. That's why they're just in the sandbox. Okay, so that's about it. General state gives you uh, Faucet S1 and config, which are used by test ZS fifth, which is called by should be called by your validator engine, as I'm doing here, or not by your validator engine, but by your master.sh script, whatever script it is that's initializing your setup, and then once you have that, you can just run your validator engine. Uh, I guess we wanted to show off the Blockchain Explorer a little bit and learn a bit about that. uh, so if we recall, we've hard coded um, the faucet address to all sevens, right? And we can see that happening in our test ZS fifth under sandbox. We can see that here, all ones, seven. So this basically gives you -1, 7 through 7. And we can plug that in to take a look at it in our Blockchain Explorer. So to easily grab that, I'm going to go into the code, which I've got hard coded in the test faucet v3. I can take any of these and throw it in the account search and view it. So we're now looking at our faucet contract. We know that here's the address, sevens, all sevens. Make sure we go to current state so we can see what the last transaction is. The last transaction, if I recall, should have been uh, an unsuccessful sponsoring. It, remember, it tried to sponsor a beneficiary and it exited with code 105. And we can go into our contract, um, which is under the config. Config is what it has the code, so it's what you go to for everything. The configuration is everything that's in the code, and the beginning sponsorship price, max beneficiaries, all that. So if we look for 105 here, we see that, oh, okay, uh, this was an exception was thrown. Exception 105 was thrown because the number of bins was not less than the max bins, and that's why it got denied. The previous uh, transaction before that, if we go to the previous transaction here, was the same thing. Remember, because we had the first five worked, but seven didn't. We could see the exit code was also 105. And then we go to the previous transaction, I mean, and this one should have exited with exit code 0 and result code 0. Uh, that means that the, it did get sponsored. You can also see that it sent some grams out here, and it 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 sent grams here too. So I believe this is two messages here, right? Because it sends gram to the sponsor, and then it sends grams to the benefactor, and that's what you're seeing here. It's They could have done this a lot better, but this is what we have for now. I mean, this is how you this is how you work with Ton for now. Things could be a lot better. they need devs, smart devs, good devs, really working on this stuff, and it could be a gem, but it's it's gonna need a lot of work. Um, all right, so we should see this 5 times. This is one. Uh, this hold on, what did I do? Okay, I did go back. This is two. This is three. This is four, and this is five. So we should see exit. Same thing. This should be the first sponsorship because we're kind of going back in time. If you're unsure what's going on here, we're going back in time to the first sponsor. All right. So we also have another transaction. What is this? If you were paying attention, well, if this is the first time you watch a video, there's no way. But I know what this is. This is the reset operation. This is the message. That's why it's a or maybe I'm wrong, or maybe I miscounted or something. Um, I expected this to say external. Oh, okay, so I am wrong. This is the initial sponsorship message. That's why the value is 333. This is when Maine just sent some gram to the contract, and it was the first one to do it, so it became the main sponsor, the big daddy of them all. Okay, so then the previous transaction should be an external, right? The type external, and it's the reset operation that we do. We do that every time we run the test so that it deletes all the user data. But of course, and you should have no previous transactions, right? Because that was the first transaction that our Faucet contract ever received, and so we have no previous transactions. But if you run the test several times, it may be hard to go through here and navigate inside here because you might lose track of which test you ran. So you may end up wanting to just restart your validator engine all over again. Um, and that's why I think better tools are definitely necessary because uh, it's hard to navigate. And once you get to the point where you can't just reset the zero state anymore, and you have to work with what is there. You're not gonna have the luxury of resetting the zero state because it's live, and so you need other better tools. Um, I hope that explains everything that we're doing and how basically to do it. And of course, we're always available if you have any questions. I'm gonna go ahead and end there.